Get ready to challenge everything you thought you knew about humanoid robots, because Tesla's Optimus Gen 3 is not just evolving, it's poised to redefine what a machine can truly achieve, from factory floors to your own home. Elon Musk has boldly declared that this humanoid robot will become a full food server by 2026, delivering meals directly to vehicles at supercharger stations. While the latest third-generation Optimus might initially handle simpler tasks like serving popcorn, a rapid expansion of its responsibilities is entirely plausible. Optimus now boasts enhanced hand control, powered by 50 actuators and an impressive 22 degrees of freedom per hand, enabling movements far more precise and flexible than ever before. Beyond basic grasping, these hands can now press, smooth, squeeze, and twist small objects with remarkable dexterity. Its capabilities are further strengthened by Tesla's new AI 5 chip, which significantly boosts processing power and supports advanced voice interaction through Grok. This raises critical questions. What exactly will the Tesla Bot Gen 3 be capable of when it goes on sale in 2026? And can a single Optimus robot truly work in a factory and serve in a restaurant? Some critics bluntly state that Optimus 2 was a joke, and it's difficult to ignore such skepticism. Whether Optimus Gen 3 truly delivers a breakthrough remains uncertain. While the concept of robots serving food at charging stations sounds futuristic, for some, it evokes an unsettling feeling rather than genuine innovation. But the core concern extends beyond practicality. Is this all truly real? A closer look reveals a familiar pattern. Typically, a disruptive product follows a predictable journey: working prototypes, real-world testing, early adopters, pre-orders, and validation. With Optimus, this sequence appears to be accelerated or even partially bypassed. Moreover, questions arise about Elon Musk's current positioning as the architect of humanoid robots. Not long ago, many considered the Cybertruck Tesla's most audacious creation. Now, we're discussing robots that some fear might amount to little more than demo dancers, or, in a worst-case scenario, if FSD falters, perhaps Optimus will simply occupy the driver's seat. Currently, much of the buzz centers on one particular feature: its incredibly advanced hand. We've seen glimpses and heard much about it, but perhaps not enough to fully believe all the ambitious claims. Meanwhile, competitors, particularly in China, are already deploying humanoid robots in real-world applications, some arguably leading in practical implementation. Yet, upon examining the latest images of Optimus Gen 3, what truly astonished observers wasn't its Terminator-like aesthetic, but its hands. Many are hailing this as the iPhone moment for robotics, because replicating the dexterity of the human hand has long been the field's most formidable physical challenge. While earlier versions and competing robots were confined to basic grip and hold functions with roughly 11 degrees of freedom, the leap to 22 degrees in Gen 3 is transformative. These are no longer rigid metal fingers executing pre-programmed movements. With 22 degrees of freedom, each joint operates like a complex pulley system, enabling delicate, human-like actions from gently brushing fabric to precisely handling soft, fragile objects. Despite some skeptics suggesting these demonstrations might be staged or remotely controlled, Tesla has shown that the hand is engineered as a true biomechanical system, far beyond a simple industrial tool. However, such complexity inevitably raises concerns about durability. Highly intricate mechanisms are often maintenance nightmares, where even a speck of dust or debris could lead to failure. Tesla addresses this with a smooth, sealed outer shell, reminiscent of a premium glove, an ingenious engineering solution that protects internal motors and sensors, allowing Optimus to function in real-world environments, not merely pristine laboratories. Another significant debate revolves around whether these hands possess tactile sensation. Without genuine tactile feedback, movement alone would render Optimus little more than a sophisticated puppet. Instead of relying on thousands of costly sensors, Tesla ingeniously leverages its AI-5, powered computer vision, enabling the robot to estimate force through machine learning, much like humans acquire coordination during early development. Ultimately, these hands are the clearest indication that Optimus is transitioning from a mere demonstration piece into a genuine working machine. They unlock the potential for tasks demanding extreme precision, such as assembling electronics or assisting with intricate household chores. It's a bold and high-stakes gamble, but if Tesla can ensure reliability at scale and maintain low costs, it could herald the end of the traditional gripper-based robot era. Few anticipated Tesla showcasing nearly 50 humanoid robots alongside 2 fully autonomous vehicles at a single event, offering attendees the rare opportunity for direct interaction. The experience far exceeded expectations. While only dozens were visibly displayed, it's highly probable that Tesla has already manufactured many more. By strategically reusing core technologies from its electric vehicles, including batteries, motors, power electronics, and AI, the company has dramatically accelerated development. This approach, rather than starting from scratch, enables Tesla Bot Gen 3 to scale rapidly with ambitious plans for mass production in the near future. Elon Musk consistently highlights that virtually every innovation developed for Tesla's cars is applicable to humanoid robots. In his perspective, autonomous vehicles themselves are a type of robot, simply lacking limbs. By incorporating arms and legs, Tesla Bot Gen 3 gains the ability to operate effectively in human environments, performing tasks like climbing stairs, utilizing tools, and handling objects with remarkable flexibility. Earlier demonstrations of the robot, which were limited to simple actions such as folding clothes or sorting components, often left observers unconvinced. People sought practical value in real-world applications. This perception shifted dramatically at the recent We Robot event, where Tesla Bot Gen 3 was demonstrated operating outside controlled laboratory conditions. Unlike previous exhibitions where robots were showcased behind protective glass, attendees could now directly observe and interact with them. But how realistic is the projected 2027 release roadmap? It's crucial not to perceive the 2027 milestone as a far-off promise, because an industrial revolution is currently unfolding within Tesla's Fremont factory. The most compelling evidence is Elon Musk's decisive move to halt the Model S and Model X production lines, making way for Line 1, the world's first dedicated robot production line, targeting an astounding capacity of 1 million units per year. This signifies a clear transition beyond the research and development phase. This is the true S-ramp phase of production. A close examination of leaked footage from the Autonomy pop-up event in Austin in mid-March reveals critical details that Tesla never explicitly disclosed in its presentations. While promotional videos depict Optimus smoothly serving drinks, on-site outdoor test units were observed still connected to ultra-thin tether cables. This indicates Tesla is rigorously testing a new safety protocol, a hardware-level emergency cutoff switch designed to prevent the robot from losing AI control during interactions with crowds. Furthermore, under high-contrast lighting, tiny redesigned heat vents are visible at the back of Optimus Gen 3's neck and along its spine. This confirms that the AI-5 chip is operating at extremely high power to run end-to-end neural networks. Tesla has ingeniously adapted cooling technology from Model 3 inverters to prevent the robot's brain from overheating during continuous 7-hour operation. Another rarely noticed detail is the Gen 3's more rounded shoulder joints, with all exposed wiring completely eliminated. This signifies Tesla's success in integrating the entire wiring system within a monolithic gigacasting frame, an unprecedented engineering feat in humanoid robotics. In terms of real-world tasks, Optimus is no longer merely folding clothes at a leisurely pace. Internal reports from Giga Texas indicate that the first Gen 3 units have already been deployed to logistics teams, tasked with transporting component trays between assembly stations. This represents a rigorous test, operating within a chaotic factory environment, bustling with noise and autonomous forklifts. The robot's impressive ability to localize itself in 3D space without reliance on guide tape or preloaded maps powerfully demonstrates that the AI-5 brain is truly prepared for complex challenges. While a $20,000 price tag might initially spark skepticism, it's crucial to consider the ambitious reality Tesla is forging. A manufacturing ecosystem in Texas designed to produce 10 million units per year. At such an unprecedented scale, the cost of each actuator module could plummet to the level of a car window regulator. Tesla isn't merely building robots. It's fundamentally redefining mass production to transform Optimus into a ubiquitous household device by the summer of 2027. It's frequently argued that Optimus could emerge as a significant cost-saving solution if it proves capable of handling a diverse array of household tasks. This leads to an intriguing thought experiment. If you had between $25,000 and $30,000, would you choose a Tesla bot or a Tesla cybercab? It's not an easy decision. From a consumer perspective, one might actually favor the Tesla bot over electric vehicles like the Model Y, Model 3, or even the forthcoming Tesla Cybercab. The rationale is straightforward. If the robot can genuinely assume useful tasks and reduce expenses, it could offer more practical, daily value. Now, extend that capability to a different environment, such as a retail setting. Instead of merely organizing garments, the robot could efficiently fold large volumes of clothing, package them into boxes, and prepare them for shipping. This could potentially eliminate the need to hire staff for packing or incur ongoing wage costs. If Optimus can manage income-generating tasks, like logistics or light manufacturing, it could substantially cut operating expenses while simultaneously creating new revenue streams. Over time, the savings and income generated could be reinvested into acquiring additional robots, thereby amplifying overall returns. In such a scenario, these machines would essentially cover their own costs, eventually making it more feasible to afford something like a new Tesla EV. This perspective positions an upfront investment in robots as a highly strategic choice. So, how does the Tesla bot Gen 3 overcome the daunting challenge of a 10-hour energy demand? If the hands are Optimus's face, then its battery pack defines its very survival limits. Many are questioning how a 3 kilowatt-hour battery can power dozens of high-output motors through an entire work shift. The ingenious answer lies not in sheer size, but in a groundbreaking shift in battery chemistry and power consumption architecture that Tesla has subtly implemented. The first key insight stems from Tesla's strategic partnership with LG Energy Solution, unveiled in early 2026. Instead of utilizing the heavier, lower-cost lithium iron phosphate batteries found in standard vehicles, Optimus Gen 3 is equipped with next-generation nickel-manganese cobalt cells. Why this choice for robotics? Weight is the paramount adversary. Every additional gram in the torso forces hip and knee motors to expend more energy simply to maintain balance. With a significantly higher energy density, estimated at 400 watt-hours per kilogram in recent tests, nickel-manganese cobalt allows Tesla to pack greater capacity into a smaller space. This enables Optimus to retain its human-like slim form while operating continuously for 8 to 10 hours, impressively surpassing the original 7-hour target. A subtle detail, often overlooked on the Gen 3's back, is Tesla's implementation of an ultra-thin liquid cooling system directly inspired by the octovalve used in the Model Y. In test videos depicting the robot running at 8 kilometers per hour, there are no signs of stuttering or performance degradation due to overheating. This powerfully demonstrates that the thermal system has successfully resolved the consumption loop problem, where increased activity raises battery temperature and consequently reduces efficiency. Maintaining optimal battery temperature not only extends operating time, but also dramatically increases cell lifespan to thousands of cycles, a critical factor in achieving an operating cost as low as 32 cents per charge. Even more. Interestingly, data analysts have identified an unannounced feature, eco-inference mode. When performing simple tasks like standing or slow movement, the AI-5 chip automatically lowers clock speeds and deactivates unnecessary actuator clusters. This allows Optimus to optimize energy usage with remarkable efficiency, much like the human body. Notably, leaked images from the Austin factory reveal that Optimus charging stations are no longer bulky plug-in systems. The robot can now autonomously align itself and lean back onto wireless charging docks using magnetic contacts on its back, strikingly similar to how robotic vacuums return to their bases. This energy autonomy is fundamental to realizing the vision of a tireless robotic workforce, where robots seamlessly recharge during human breaks and resume work once fully powered. Tesla is not merely constructing a walking robot. It is creating an intelligent, mobile energy system capable of managing every single milliwatt, transforming 3 kilowatt-hours into a revolution in labor productivity. So, when can the Tesla bot truly be utilized for the elderly and children? While the matte black exterior of Optimus Gen 3 still evokes a Terminator image for many, what's unfolding within Optimus Academy, Tesla's clandestine AI training center, reveals a profoundly different narrative. Here, robots are not being programmed for combat. Instead, they are learning to make tea, clean homes, and, most crucially, to care for the elderly. The clearest evidence for this lies in the upgraded tactile sensor system integrated into its fingertips, a feature unveiled in early 2026. Analysts in recent demo videos have observed a subtle yet significant detail. When Optimus holds an elderly person's hand to assist with walking, its AI-5 algorithms process thousands of signals per second. This ensures the grip is firm enough for support, yet gentle enough to meticulously avoid bruising fragile skin, an unprecedented achievement for traditional industrial robots. Tesla is also discreetly integrating a never-before-seen feature, fall detection and emergency response. Utilizing its FSD camera system, Optimus can instantly recognize when someone falls, swiftly assess the severity, and immediately initiate a video call to family members or emergency services. Internal test footage even shows the robot demonstrating the ability to use its own body as support to help users safely stand up. However, this particular application has ignited intense ethical debates, especially in the US. Many contend that a soulless machine cannot provide emotional comfort, expressing fears that replacing human caregivers could exacerbate deep loneliness among the elderly. In response, Tesla appears to be planning the integration of large language models, akin to Grok, with the aim of transforming Optimus into a conversational companion capable of medication reminders and even storytelling tailored to user preferences. A significant technical challenge, often overlooked, is hygiene. To function effectively in home and healthcare environments, Optimus Gen 3 has been engineered with water-resistant and antibacterial features in key contact areas. This design enables it to assist with basic personal hygiene tasks, which currently represent one of the most substantial burdens for in-home caregivers. Tesla is not merely aiming to sell a household assistant. It is targeting a comprehensive solution to the global demographic crisis. As populations age and the young workforce diminishes, Optimus could become a vital lifeline, helping the elderly maintain independence and safety within their own homes. However, to achieve this ambitious goal, Tesla must prove that this combination of metal and advanced AI can genuinely deliver what we call care, a barrier of trust, even more formidable than the technological one. The concept of Optimus as a homemaker is increasingly likely to become Tesla's primary focus. A robot confined to factory work would hold limited appeal for most consumers, but one capable of assisting at home offers immensely greater value. Recent demonstrations strongly hint at this strategic direction. In one video, Optimus smoothly folds a shirt in approximately 30 seconds with precise, controlled movements. Imagine a future where it completely manages your laundry folding, organizing, and storing clothes while you relax. This vision closely aligns with Tesla's ultimate objective. Unlike humans, robots can operate continuously without succumbing to fatigue. Early versions of Optimus are equipped with a 5.2-volt, 3 kilowatt-hour battery, enabling extended operation without frequent charging. Even as newer versions become lighter, this capacity remains highly practical, combined with its ability to lift up to 24 kilograms. Optimus is engineered for both endurance and practical physical strength within daily environments. Its capabilities extend far beyond basic chores. With its dexterous hands and multiple degrees of freedom, Optimus can manage an extensive array of household tasks. Cleaning could become effortless as the robot operates tools, controls appliances like vacuum cleaners, and maintains tidy spaces. It can also assist in the kitchen by preparing simple meals and handling cleanup afterward, improving its efficiency with each use through continuous learning. Beyond indoor tasks, Optimus may extend its utility outdoors. It could manage light agricultural duties such as watering plants, trimming, or basic garden maintenance. Tesla has even suggested the robot could perform delicate manual actions requiring significant precision, underscoring its potential versatility. Education and caregiving are also pivotal areas. Optimus could read to children, assist with homework, and provide rapid access to information, serving as a supportive learning companion. For elderly users, it could aid with mobility, daily routines, and medication reminders, offering both physical and cognitive support. Furthermore, the robot may function as a practical home assistant for maintenance and safety. From rectifying minor issues like replacing light bulbs to detecting hazards such as gas leaks or fire risks, Optimus could substantially enhance household safety. These combined functionalities suggest that a price point around $20,000 could be thoroughly justified by the profound value it delivers. Elon Musk has previously stated that Tesla bots are initially intended for repetitive and dangerous industrial tasks, but the long-term vision is to integrate them into millions of homes for activities like cooking, yard work, and caregiving. This indicates that such applications are not merely hypothetical, but form an integral part of a broader, strategic roadmap. That said, current versions are still undergoing rapid evolution and are unlikely to achieve all these sophisticated capabilities immediately. As Tesla progresses toward limited releases, real-world performance will become increasingly clear. If Optimus eventually fulfills this expansive vision, it could dramatically reduce both time and labor costs, making it a truly transformative addition to everyday life.